Title: The Intricate Dance of the Weather, a comprehensive exploration. Introduction: The weather, an ever-changing and dynamic phenomenon, has captivated the human imagination since time immemorial. It holds immense significance in our lives, shaping our daily routines, influencing our moods, and dictating the course of numerous natural processes. From the gentle touch of a warm breeze on a sunny day to the awe-inspiring power of a thunderstorm, weather's myriad manifestations both enthrall and impact us in countless ways. This essay delves into the multifaceted nature of the weather, exploring its various elements, patterns, and the scientific principles behind its occurrence. The atmosphere and its composition. At the heart of weather lies the Earth's atmosphere, an intricate gaseous envelope that surrounds our planet. Comprising primarily nitrogen, oxygen, and trace amounts of other gases such as carbon dioxide, argon, and water vapor, the atmosphere plays a pivotal role in shaping weather patterns. Its composition influences the absorption and release of heat energy, the formation of clouds, and the distribution of atmospheric pressure. Radiation and heat transfer. One of the key driving forces behind weather phenomena is the sun's radiant energy. As sunlight reaches the Earth's surface, it undergoes several processes of energy transfer, including absorption, reflection, and scattering. The unequal heating of the Earth's surface leads to variations in temperature, creating air currents, and setting in motion a complex system of atmospheric circulation. Pressure systems and wind patterns. Differences in air temperature and pressure across the globe give rise to high and low pressure systems. Warm air, being less dense, rises, creating areas of low pressure, while cooler air descends, leading to high-pressure zones. The movement of air from high-pressure regions to low-pressure areas results in the formation of wind. These wind patterns, such as trade winds, prevailing westerlies, and polar easterlies, influence weather patterns on a global scale. Moisture and the water cycle. Water, a crucial component of weather, exists in various states within the atmosphere. Evaporation from oceans, lakes, and other water bodies converts liquid water into water vapor, which then rises, cools, and condenses to form clouds. The water cycle, encompassing processes like evaporation, condensation, precipitation, and runoff, plays a central role in the distribution of moisture and the formation of precipitation, be it rain, snow, sleet, or hail. Clouds and precipitation. Clouds, ethereal formations suspended in the sky, hold the key to predicting and understanding weather conditions. They are classified based on their appearance and altitude, ranging from fluffy cumulus clouds to high, wispy cirrus clouds. Clouds serve as indicators of atmospheric stability, moisture content, and the likelihood of precipitation. Through various mechanisms like collision and coalescence or ice crystal formation, clouds release their moisture in the form of raindrops or ice crystals, leading to precipitation. Severe weather phenomena. Weather encompasses a wide range of conditions, from the serene to the extreme. Severe weather phenomena include thunderstorms, hurricanes, tornadoes, blizzards, and droughts. These events, driven by complex interactions between temperature, moisture, and atmospheric instability, can have significant impacts on human lives, infrastructure, and the environment. Understanding their formation, tracking their paths, and implementing effective disaster preparedness measures are crucial for mitigating their potentially devastating consequences. Climate and weather variability. While weather refers to short-term atmospheric conditions, climate refers to long-term trends and patterns of weather in a specific region. Climate is influenced by a combination of factors, including the Earth's tilt, topography, ocean currents, and atmospheric circulation patterns. Variability in climate can lead to alterations in weather patterns, such as shifts in temperature, precipitation, and the frequency of extreme events. Studying climate change and its relationship with weather is essential for comprehending the future of our planet. Weather forecasting and technology. Advancements in technology have revolutionized weather forecasting, enabling us to predict and anticipate atmospheric conditions with increasing accuracy. Meteorological instruments, satellites, weather radars, and computer models have enhanced our understanding of the complex dynamics of the atmosphere. Through the collection of vast amounts of data and sophisticated analysis techniques, meteorologists can now provide short-term and long-term weather forecasts, aiding in disaster preparedness, agricultural planning, and aviation safety. Temperature, a fundamental aspect of weather, plays a pivotal role in shaping our experiences and influencing the behavior of various natural processes. It is a measure of the average kinetic energy of molecules in the air and determines whether we feel hot or cold. Temperature variations across different regions give rise to the concept of seasons, with the tilt of the Earth's axis dictating the intensity and duration of each season. Understanding temperature patterns helps us adapt our clothing choices, energy consumption, and even agricultural practices to suit the prevailing weather conditions. Humidity, the amount of water vapor present in the air, is another crucial element of weather. Humidity levels affect our comfort, as high humidity can make the air feel heavy and oppressive, while low humidity can lead to dry skin and respiratory discomfort. Additionally, humidity influences the formation and behavior of clouds, as well as the likelihood of precipitation. Meteorologists measure humidity using various metrics, such as relative humidity and dew point, to gain insights into atmospheric moisture content and predict weather conditions accurately. Wind, the horizontal movement of air, is a dynamic force that shapes weather patterns on both local and global scales. It arises from differences in atmospheric pressure and is influenced by factors such as temperature gradients, the Earth's rotation, and surface characteristics. Wind plays a crucial role in dispersing pollutants, shaping ocean currents, and influencing the formation and movement of weather systems. It also facilitates the process of evaporation, aiding in the distribution of moisture across different regions. Air pressure, the force exerted by the weight of the atmosphere, is a fundamental concept in meteorology. Changes in air pressure drive the movement of air masses and the formation of weather systems. Meteorologists use barometers to measure air pressure and analyze its patterns and variations. High-pressure systems are associated with clear skies and stable weather conditions, while low-pressure systems often bring clouds, precipitation, and sometimes severe weather events. Weather fronts, the boundaries between air masses with different temperature and moisture characteristics, are significant contributors to weather variability. Cold fronts occur when a cold air mass displaces a warmer air mass, leading to the potential for thunderstorms and heavy rainfall. Warm fronts, on the other hand, form when a warm air mass replaces a cooler air mass, typically causing steady rainfall over a larger area. Occluded fronts and stationary fronts are other types of boundary systems that influence weather patterns. The phenomenon of thunderstorms captivates both scientists and onlookers with its raw power and majestic displays. Thunderstorms form when warm, moist air rises rapidly, creating unstable atmospheric conditions. These storms are often accompanied by lightning, thunder, heavy rainfall, and sometimes hail or tornadoes. Studying the formation and behavior of thunderstorms provides valuable insights into atmospheric instability, convective processes, and the interplay of various meteorological factors. Tropical cyclones, commonly known as hurricanes or typhoons, are immense and violent storms that originate over warm ocean waters. These rotating systems feature low-pressure centers, strong winds, and intense rainfall. As they move across the ocean, they can wreak havoc when they make landfall, causing widespread destruction and posing significant risks to human life and infrastructure. Understanding the life cycle of tropical cyclones and accurately predicting their paths and intensities is crucial for effective disaster management. Winter storms, such as blizzards, can unleash a flurry of weather-related challenges. These storms occur in regions with cold temperatures, where moist air interacts with Arctic air masses. Blizzards are characterized by strong winds, heavy snowfall, and reduced visibility, making travel treacherous and causing power outages. Winter storms not only affect human activities but also impact agriculture, wildlife, and ecosystems. Monitoring and forecasting these events help communities prepare and implement necessary safety measures. Drought, an extended period of below-average precipitation, presents formidable challenges to societies and ecosystems alike. It can result from natural climate variability or be exacerbated by human activities, such as excessive water consumption or land degradation. Droughts affect agriculture, water resources, and biodiversity, causing economic hardships and food security concerns. By monitoring various climate indicators and employing water management strategies, we can mitigate the impacts of drought and enhance resilience. Weather's profound influence on human societies transcends its impact on daily routines. It affects diverse sectors, including agriculture, transportation, energy, tourism, and emergency management. Farmers rely on weather forecasts to plan planting and harvesting activities, while airlines use meteorological information to ensure safe flights. Renewable energy systems, such as wind and solar power, depend on accurate weather predictions for optimal operation. Moreover, understanding and adapting to weather patterns are vital in building resilient communities capable of responding to natural disasters and climate change. Weather events have significant implications for ecological systems and natural habitats. Ecosystems are intricately connected to weather patterns, with plant and animal species relying on specific climatic conditions for survival and reproduction. Changes in temperature, precipitation, and seasonal patterns can disrupt ecological balance, leading to shifts in species distribution, altered migration patterns, and the potential loss of biodiversity. For example, rising temperatures and altered rainfall patterns can impact the timing of flowering and breeding, affecting pollinators and leading to potential mismatches in ecological interactions. By studying the intricate relationship between weather and ecosystems, scientists can gain insights into the potential impacts of climate change on biodiversity and work towards developing conservation strategies. Weather also holds a profound influence on human emotions, behaviors, and well-being. The phenomenon known as weather and mood demonstrates how weather conditions can impact our psychological state. Sunlight and warmer temperatures often evoke feelings of happiness, while prolonged periods of gray skies and rain can lead to lower moods and increased fatigue. Additionally, weather-related phenomena such as seasonal affective disorder highlight the influence of weather patterns on mental health. Recognizing the connection between weather and human emotions can aid in developing strategies for self-care, mental health support, and urban planning that promote well-being and resilience in the face of varying weather conditions. Conclusion: the weather, a remarkable symphony of atmospheric processes, encompasses a diverse range of elements and phenomena that shape our daily lives. From the ebb and flow of wind patterns to the dance of clouds, the weather's intricate tapestry holds both beauty and power. Understanding its dynamics, exploring its scientific underpinnings, and harnessing the advancements of technology enable us to appreciate its wonders and mitigate its risks. As we continue to unravel the mysteries of the weather, we deepen our connection to the natural world and fortify our ability to adapt to its ever-changing rhythms.